Welcome to this walkthrough video of the summer 2023 paper of P3. Let's get started. Okay, question 1. It's a numerical methods question. So show that alpha has root alpha in the interval 3, 4. So this is just simply substituting 3 and 4 into it and showing a change in sign. So g of 3, so 3 to the power 6 plus 2 times 3 minus 1000, and that is negative 265. And then put in g of 4 in. So 4 to the power 6 plus 2 lots of 4 minus 1000. And that's 3104. So change in sign. Terrible at spelling. Had to really think about continuous then. It's continuous and hence root is between 3 and 4. Okay, now B part 1. Just using the iteration formula there. So to find x2, that's 1 plus 1. Yeah. So n is 1 in this case. And then this xn is x1, which is 3. And that gives me 3.159107, and we wanted to 4 decimal places, so 3.1591. And then part 2, find by repeated iteration the value of alpha. So to do this, you've got your answer in your calculator, 3.159107448, and that's the answer. And then you need to just set your calculator up. So the 6th root of 1000 minus 2, and then press the answer button. And then every time you hit equals, you get a value. If you keep on pressing equals, you'll see it'll stop. This is to 4 decimal places. So once you see the 4th decimal place stop being fixed as a value, okay, because as you keep on pressing equals, it's tending towards a value. So depending on the actual numbers, it might take a few goes, it might take a lot of goes, but each kind of decimal place locks in place. And in this case, our alpha is 3.1589 to 4 decimal places. Okay, because it was locked in place pretty quickly. Okay, question 2 is a log question, but when you use logs for your graphs, you know. So in this case, first of all, for part A, find an equation linking log t and log x. We first need to find the gradient. So the gradient here, this is A part 1. Gradient is difference in y's. So 4 minus 0 over 0 minus 2. So it's 4 over negative 2 or negative 2 as my gradient. And then it's y equals mx plus c. But in this case, y is log t and x is log x. So log t equals negative 2 log x plus c. And c is this value here where the y-intercept, so that's at 4, so it's plus 4. Now part 2 is hence find the exact value of t when x is 216, so it's log 6 of t equals minus 2 log 216 plus 4. So that is log t equals negative 2. So this must mean that t is 6 to the power negative 2, or 1 over 36. Okay, part B is find an equation not involving logs. So starting with our log equation, I'm going to write log 6x to the minus 2 plus 4 log 6 of 6, because this is just 1. Okay, then I can bring this 4 up. So I'm just going to rub it out there, and that's going to be there. So log 6 t equals log 6 of, now these are added, so 6 to the power 4 is 1296 times by x to the minus 2. So just carrying on over here, both these are logs now, the same base, so t equals this. So t equals 1296 x to the minus 2, or t equals 1296 over x squared. Okay. Of course, there is another way you can do this. You can do like what I did down here and put it in power format first, and then deal with it from there. I just find it easier to make the 4 with a log and put the logs together so there's single logs either side. But like I said, there's more than one way to do this question. Okay, to differentiate my log sine squared 3x, so we are differentiating log of sine squared 3x, so that's 1 over sine squared 3x times by this differentiated. Okay, so I'll do it over on the side, but sine squared 3x can be written as sine 3x squared. So imagine you're going to differentiate this. We bring the 2 down, sine 3x, and then we multiply by the inside differentiated. So sine differentiates to cos, and sine 3x differentiates to 3 cos 3x. So this is 6 sine 3x cos 3x. So that's what I'm going to multiply by, 6 sine 3x cos 3x. Now sine 3x will cancel with 1 on the bottom, so this is 6 cos 3x over sine 3x. Sine over cos is tan, cos over sine is cot, so this is now 6 cot 3x. Now part 2a, it's weird to have a part 2a and not like an a part 1 part 2b and so on. Right, we're differentiating this, so differentiating 3x squared minus 4 to the power 6. So bring the 6 down, 3x squared minus 4 to the power 5 times by inside the brackets differentiated, which is 6x. So this is going to give me 36x, 3x squared minus 4 to the power 5. Now part B is hence show that. So we've got x here, we've got 3x squared minus 4 to the power 5 dx, and this is going to equal r is what we're trying to find. Now this is very much the same as this. It's just a factor of 36 times bigger. So this is 36 times bigger than this. So if we divide this by 36, we'll get this, which means that the answer is this divided by 36. So 1 over 36, 3x squared minus 4 to the power 6. And then it's between root 2 and 0, and that's going to equal r. And then it's just a matter of substituting in. So 1 over 36 can stay outside. 3 times now x squared, so root 2 squared is 2. So it's just 2 there, minus 4 to the power 6, minus, and then this is just minus 4 to the power 6. And that equals r. So 64 minus 4096. So r equals negative 112. Okay, and that's all there is to it. Now this, of course, here you can check in your calculator. It gives you a numerical answer. So put that into your calculator and just double check that this is the correct answer before you move on. Okay, question 4. Now, in this one we've got a function. X is greater than or equal to 0, so state the range of f. So if we substitute 0 into here, so f of 0 is 0 minus 5, so it's minus 5, and then as I put positive values of x into here, they're just going to increase. So if I put 1 in, it's going to be 2 minus 5, so it's going to be minus 3. If I put 2 in, 2 squared is 4, times 2 is 8, minus 5 is 3, so it's just going to get bigger and bigger from here. So the range is that f is greater than or equal to negative 5. Okay, so part B, we need to sketch the inverse graph. Now this is basically a reflection in the line y equals x. Yeah, so it's going to go roughly from here and like that. I'm going to try and do that again, a bit smoother. Okay, so you don't need to put the y equals x line in, but that's roughly how it's gonna look. Now for part C, we're looking at this point being point P, where the line f of x and f to the minus 1 of x, the inverse, meet. Okay, so you know it's y equals f of x and y equals f minus 1 of x meet, but they also meet y equals x as well, as I've shown here. Okay, they always meet there, so you don't need to equate these two. You can equate the function with x. Okay, and that's a lot easier than equating it with its inverse. So 2x squared minus 5 equals x. So 2x squared minus x minus 5 equals 0. So x equals, now this doesn't factorize, so minus b plus or minus square root b squared minus 4 times a times c all over 2a. So that's going to be 1 plus or minus square root of 41 over 4. Now it says find the exact coordinate. Now we know that this is going to be a positive coordinate. Okay, obviously these two might meet another place if the function wasn't greater than or equal to 0. So therefore the p's x coordinate is 1 plus root 41 over 4. Okay, and you must state this point. Okay, and this point you should start off with a plus or minus because you've got to justify it. Okay, so you know, I could say since x greater than or equal to 0, x equals that. Something like that. But it's better to always justify your answers. It is something that is starting to creep more and more into exams. So part 1 for this one, we've got x equals 2 or sec x equals negative 2 over root 3, which means that cos x is root 3 over 2, negative 2. Okay, and then I've got to take this one and find the answer between 0 and pi. And x is pi by 6. Sorry, I forgot the minus then. 5 pi by 6. Now if you look at the cost diagram between 0 and pi, there's only going to be one answer when cos is negative. Okay, it's here between pi by 2 and pi, which 5/6 pi is. Okay, so there's only one answer to part 1. It's the 2 and the 5 pi by 6. Now let's move on to part 2. Okay, 10 sine theta minus 3. Now cos 2 theta. So cos 2 theta can be quite a few things. Since we're dealing with sine, 1 minus 2 sine squared theta will be the most appropriate substitution. So 1 minus 2 sine squared theta there. So expanding my bracket, I get that. So 6 sine squared theta plus 10 sine theta minus 3 equals 0. Now this isn't going to be able to solve this, factorize it, but sine theta is going to be equal to minus 5 plus or minus square root of 43 over 6. Okay, so I'm just saving a little bit of time there, but use the formula to find out that answer. Now because it's plus or minus, it's going to give me 4 answers. So in my cost diagram, I'm going to be here and here for the positive values. and then here and here for the negative values. So between 0 and 360 I'm going to have an answer in all 4 quadrants. Okay, so first things first, just pop my calculator back into degrees, as this is in degrees. So the positive angle gives me 15 degrees, or 15.0 degrees. And then if you think of your cast diagram, that's that one. The next place that's positive is there, so it's 180 minus that, so it's 165 degrees there. Okay, now when I put the negative one in, so minus 5 minus root 43 over 6, I get the angle of, or the answer of, minus 1.926. Now that's going to be outside the range because sine is only between 1 and minus 1. So if I try and do inverse sine of that, it's going to give me a math error on my calculator because it's not possible. So actually there's not 4 answers to this one, there's only 2 answers, and these are the 2 answers. Okay. Okay, question 6. So we're going to find the coordinates of P. P is the vertex. So that's going to be the point here that makes this 0. It's going to be your minimum value. Okay, so your y value is going to be minus 10. It's going to be the minimum value, and when we get that when x equals 2. So it's just going to be 2 minus 10. Okay, nothing too difficult about that. Now ff of 0. So part B now, we'll put in ff of 0. So first we want to put 0 into this. So it's going to be f of, now putting the 0 into this will give me, so I'll just do it on the side, 3 mod 0 minus 2 mod minus 10. So minus 2 here, with the modulus sign we'll turn it to a positive 2, times by 3 is 6. So this is 6 minus 10, which is negative 4. So we'll put a negative 4 into our f of x. So that is 3 mod negative 4 minus 2 and minus 10. So negative 4 minus 2 is negative 6, which is positive 6. So 3 times 6 is 18, minus 10 is 8. So part C now, solve this inequality. So this is my f of x, this one 5x plus 10. If you were drawing that, gradient of 5 hitting the y-axis at 10, it's going to be something like that. It's going to be steeper than this because this is just 3 times x, isn't it? Whereas this is a 5x, so it's going to be steeper. So it's not going to hit that one, it's just going to hit that one in one place. And it's going to hit on the negative side, okay, because when x is positive, this modulus sign doesn't affect it, this part. When it's negative, it does affect it. So this is going to be minus 3x minus 2 minus 10 equals 5x plus 10. So that's what we need to solve first of all. And that's to find our critical value. 6 minus 10 is so minus 3x minus 4. So it's 8x minus 14. So x is minus 14 over 8, or minus 7 over 4. Okay, so that's my critical value. So it's going to be that point there where they meet, and then we've got to work out whether I'm looking at greater than that value or less than that value. So this is when my graph is below this one. So this is this graph, and when f of x is below it, well, this side of it, it's above that graph, and then to the right, this graph is lower than this graph. So I want it to the right, so x is greater than minus 7 over 4. Okay, and it's not greater than or equal to because we just had a less than in there. Now, if you didn't do a little sketch so you knew that it crossed here, you would have to do this twice, one with the negative and one with the positive. You'd get two answers, and then you'd have to substitute it back into the inequality, both answers, to check them. One of them would be this answer, which would work out correct. Okay, and then one of them would be another answer which when you put into the inequality it wouldn't work out, wouldn't make sense. Okay, part D, solve that equation. So there's two ways to look at this. So mod x means that the positive side of the x is reflected in the negative side. So this goes like this, and then goes like this. So this is now my graph. Yeah, and we're going to find these two values there where it equals 0. So if I think of this 3 x minus 2 minus 10 equals 0, then I've got 3 x minus 2 equals 10, x minus 2 equals 10 over 3. Actually, I won't do that straight away. I'll do 3x minus 6 equals 10, 3x equals 16, x equals 16 over 3. Just because 10 over 3 plus 2 couldn't really do it in my head. So that's 16 over 3, so that's 16 over 3, which means this value is minus 16 over 3. So x equals 16 over 3 and x equals minus 16 over 3. I can state them both like that now because also I've shown my sketch. So it's the same on both sides. Okay, you could solve it with the modulus, keeping the modulus around the x, and then state the positive and negative afterwards. But that's probably the easiest way to do that question. Okay, so for part A, we're going to find A and find the exact value of A and the value of K to 4 significant figures. So there were 2,500 bacteria at the start of this study. So when t equals 0, e to the power 0 is 1. So A is just going to be equal to 2,500. So I can right off the bat do that because 2,500 at the start is A e to the power 0. Okay, so that's the start. Now 10,000 bacteria 8 hours later. So 10,000 bacteria 8 hours later, so that's 8k. So e to the 8k is going to equal 4. 10,000 divided by 2,500. This is going to be 8k equals log 4. K equals 1/8 log 4. Now it doesn't say an exact value, it says 4 significant figures. So 1/8 log 4 divided by 8, 0.1733. So the rate, so part B now, we've got a second model, which is this one. Find the rate of decrease of bacteria in this population exactly 5 hours from the start. So rate means differentiation. So dn by dt. So we got the 60,000 times by minus 0.6. So minus 36,000 e to the minus 0.6t. Remember, when you're differentiating something in terms of e, it stays the same, and you multiply by this differentiated. So multiplying the 60,000 by minus 0.6. Now we're going to do this when t is 5. Times 5. So times e to the minus 0.6 times 5, and that gives me 1 or minus 1792.334, and it's the 3 significant figures, so minus 1790, or decrease of 1790, however you want to look at it. And part C, when t equals capital T, the number of bacteria in the two different populations are the same. Find t, giving your answer to 3 significant figures. So 2,500 e, so 0.1733 capital T equals 60,000 e to the minus 0.6 capital T. So 60,000 divided by 2,500. So I'll just do that first of all. So it's 24e to the minus 0.6 t. Now, dealing with these, now negative power is like 1 over, isn't it? So e to the 0.6 t. And then times by this to the other side. So e to the 0.1733 t plus 0.6 t, because we can put them both together then. So that gives me e to the 0.7733 t equals 24. Okay, so 0.7733 t equals log 24. Divide by this, t equals 1 over 0.7733 log 24. And that's 4.10972951. And it's the 3 significant figures, so 4.1, what am I doing? 11. The 3 significant figures. And there we have it. Quite an easy, straightforward question, I think. This paper has actually been quite nice so far, first 7 questions. Oh, maybe I spoke too soon. Okay, part A. So we've got to differentiate, and it is our product rule. So u is 2x plus 1 cubed, v is e to the minus 4x. So du by dx is 3, 2x plus 1 squared times by 2, or 6, 2x plus 1 squared. And dv by dx is minus 4e to the minus 4x. So it's u times dv by dx, so minus 4 2x plus 1 cubed e to the minus 4x, plus we get 6 2x plus 1 squared e to the minus 4x. Okay, now we don't leave it like that. Okay, you can see here there's no plus in there, but we wouldn't leave it like this anyway, because look, I've got common terms. This is in both. This is squared here and this is cubed. That's like just having an x squared and x cubed in both, you know. So you've got to factorize out, and the 6 and the minus 4, well, 2 goes into that. So factorize everything out. So take the 2 out, 2x plus 1 squared out, and e to the minus 4x out. Okay, so that leaves me, so I've taken out of this 2x plus 1 squared, and this. So I've got minus 2 left, and 2x plus 1. So minus 2x plus 1. And then out of this one, I've taken the 2x plus 1 squared and e, and then I've taken 2 out of this, so it's just 3. So 2x plus 1 squared e to the minus 4x, and then I'm just sorting out this bit. So we've got minus 4x minus 2 plus 3. So 2x plus 1 squared e to the minus 4x, and minus 2 plus 3 is 1, so 1 minus 4x in the brackets. Okay, and that's what we got there, 1 minus 4x. Now they've just chucked that at the end, but it's the same. But I will write it in that way, so 2x plus 1 squared, 1 minus 4x, e to the minus 4x, and a equals 2. Okay, so 4 marks there. Have I done a little bit slow? Yeah, maybe, but under 4 minutes anyway, which is what we're aiming for, you know, a minute a mark. Now part B, hence find the exact coordinates of the 2 stationary points on C. Right, that's the next bit. So B, we're looking at f dash of x equaling 0. So when it equals 0, the brackets are going to be 0. So 2x plus 1 equals 0, and 1 minus 4x equals 0. So x equals minus a half. Take the 4 over there, so x equals 1/4. So there's my answers to. Oh wait, those are the x values. It's very easy to make this mistake. I almost went on to C then. It's the coordinates you want to find. Yeah, exact coordinates. So we need the y values. So we need to substitute those values into here. So f of x equals 2 times minus a half plus 1 cubed e to the minus 4 times minus a half. So this one equals 0. And now putting a quarter in, so 2 times 1/4 plus 1 cubed e to the minus 4 times 1/4. So that's 27 over 8 e to the minus 1, or 27 over 8e. So here are my coordinates: minus a half, 0, and 1/4, 27 over 8e. And that's just under 2 minutes as a 3-mark question. So we're saving a bit of time there. And let's go on to C. So part C, the function g is defined by this. Find the coordinates of the maximum stationary point on the curve with equation y equals g of x. So if we think about the maximum point, the maximum stationary point here, what I'm just doing there, is going to be the quarter 27 over 8e. Okay, and what I'm doing here is I'm moving it to the right. So a quarter plus 2, this is part C, quarter plus 2 is 9 over 4, moving it 2 to the right, and I'm multiplying the y by 8. So 27 over 8e times by 8 is 27 over e. Okay, and then that's all there is to part C. So you just need to think it through. No real calculations involved there. Nice and easy. Right, penultimate question. Right, show that equals that. Okay, so show that. So you want to start with this one with the left hand side. So left hand side equals, so this is cos 2x over sine x plus sine 2x over cos x. Just writing it down again, no problems there. So cos 2x is the one with a bit of a problem. So I'm going to change it to 1 minus 2 sine squared x. Otherwise, as it's over sine x. And then we've got sine 2x is 2 sine x cos x over cos x. So those will cancel straight away. Now 1 over sine x minus 2 sine squared x over sine x plus 2 sine x. So that will cancel with that. And we got 1 over sine x is cosec x. And we've got minus 2 sine x plus 2 sine x. Those two will cancel, just leave me with the cosec x, which equals the right hand side. Okay. Okay, part B. Just shrunk this down to give me a bit more room. Hence solve that. So 2 theta 2x, 2 theta 2x, x. So it's just the same as that but squared. So that means cosec theta squared equals 6 cot theta minus 4. And we know that 1 plus, as I was saying, is cot squared theta is equal to cosec squared theta. Yeah, so 1 plus cot squared theta equals 6 cot theta minus 4. So cot squared theta minus 6 cot theta plus 5 equals 0. So that means that this does factorize. They're both minus. isn't it? Cot squared minus 1 minus 5 is minus 6 plus 5, yeah. So cot theta equals 5, or cot theta equals 1. So that means tan theta equals 1/5, or tan theta equals 1. So those are my 2 bits. Now we've got to do this between 0 and pi by 2, so 0 and 90. So this one gives me, just put my calculator in radian mode there, 0.197 to 3 significant figures, yeah. And theta equals, so when it's 1, it's 45 degrees, so that's pi by 4. Okay, now let's get on to part C. So part C is using the integration pi by 4 pi by 6. So it's going to be cosec x cot x dx. Just swapping this out now with the cosec. Okay, so this one now is quite easy. Equals minus cosec x. Now, if you don't know that, it's in the formula booklet. But in the formula booklet, at least the older ones, you have to look in the differentiation section. So when you go from the differential, like f dash of x to f of x, will be integrating. So in that, like cosec differentiates to minus cosec cot. So cosec cot integrates to minus cosec. Okay, and then I just need to substitute these values in. So cosec pi by 4 minus cosec pi by 6. So this is minus root 2 minus 2. Obviously, this being cosec, you just put in sine. So minus sine pi by 4 and then flip it. Okay, you can use the x to the minus 1 button in your calculator to flip it if you wish. So we've got 2 minus root 2. It's just an exact value, so that will be it. Now on to the final question. Okay, so we've got a curve, this is it, find dx by dy, so we're just differentiating this. So we're looking at differentiating this, x equals 2y squared plus 6 over 3y minus 3. So I want to call this u and v. Yeah, so u equals 2y squared plus 6 du by dy is 4y, and v equals 3y minus 3 dv by dy is just 3. Then quotient rule, so dx by dy is going to be dv du by dy, so these two multiplied, so 4y 3y minus 3 minus u dv by dy, so 3 times 2y squared plus 6 all over v squared, so 3y minus 3 squared. Now normally I'd leave it like that, but it does say fully simplified fraction, so we need to simplify it further. So not 4, it's going to be 12y squared minus 12y minus 6y squared minus 18 over 3y minus 3 squared. So that's going to give me 6y squared minus 12y minus 18. Now I can take the 6 out, so y squared minus 2y minus 3. And the bottom one, I can take the 3 out, but it's squared, so I'll be taking out 9. Y minus 1 squared. So I'm just taking 3 out of both of these, but it's 3 squared coming out. So this is going to simply be dividing top and bottom by 3. And that is then all we can probably do to this. So 2y squared minus 4y minus 6 over 3y minus 1 squared. Okay. Okay, part B. So we've got tangents at P and Q are parallel to the y-axis as shown on the curve. So this is now going to be when dx by dy equals 0. So dx by dy equals 0, which means 2y squared minus 4y minus 6 equals 0. So this factorizes. Yeah, take a 2 outside, or divide by 2 first of all. So y squared minus 4y minus 3 equals 0. So it's 3 and 1. Oh, sorry. Not minus 4. I was wondering then. 2y. So 3 and 1. The 3 is minus, and the 1 is plus. So y equals negative 1, y equals 3. And now I need to substitute these into this. So into this. So x equals 2 times minus 1 squared plus 6 over 3 times minus 1 minus 3. So it's 2 plus 6 is 8. Minus 3 minus 3 minus 6. This is minus 4/3. So x equals minus 4/3 is one line, and that is what we'd expect to see. You know, it is a vertical line, so it's going to be an x equals. And substituting the 3 in, we get 2 times 9 is 18 plus 6, 18, 24. And then we got 9 plus 3 is 12. So that is 2. So x equals 2 is our second equation. No, sorry, I made a mistake there. That's right, I made the mistake. Minus 3. So 24 over 9 minus 3 is 6. There we are, that's 4. So x equals 4 is my second equation there. Just worth double checking. So just looking at this side and thought, well, hang on, change the sign. Randomly do that. I met a student years ago that just used to randomly change plus and minus signs through their working out, and they couldn't get out of it. They would have had 100% on everything, but that just constantly meant they dropped marks. Anyway, that's the last question done. If you found this video useful, you know, like, subscribe, comment down below, all the usual. I am starting to get back to doing some videos. Hopefully I can keep it up now I'm back to, well, kind of full health. So yeah, stay tuned for the next video.